In Lesson 4.1, Graphing Equations in Slope-Intercept Form, Example 5, you'll be modeling real-world data with equations in slope-intercept form. In this example, it says use the information at the left about high school sports. Write a linear equation to find the number of girls in high school sports after 1997. It says in 1997, about 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of 0.06 million per year since 1997. Well, since it's increased by 0.06 million per year since 1997, it's going to be 0.06 times the number of years since 1997. And then we're going to add to that what it started at. It started at 2.6 million. So the equation is G, or the number of girls competing, is equal to 0.06n plus 2.6. Now to graph that equation, we know the y-intercept is 2.6 million. So when we make a graph, we're going to put the years along the bottom, the years since 1997, and along the side, it's going to be the number of girls in sports. You have to make sure that you are going up by equal intervals. In this graph, we went up by half millions, and then we went up by just single years on the x-axis. Now we know the y-intercept is 2.6, so we can put that point on the graph. And then the slope is 0.06, or it goes up 0.06 million per year. That's going to be kind of hard to graph on here just by doing rise over run. It's going to be hard to go up 0.06 over 1. So you may want to just choose some different numbers for years. Plug it in and see what you get. Like maybe let's try 5 years. If I plugged in 5 years, I would have the number of girls is going to equal 0.06 times 5 years plus 2.6. Now 0.06 times 5 is 0.3, and then add that to 2.6, and you get about 2.9 million. So when the number of years is 5 years since 1997, it's going to be just under 3 million. So it's right below the 3. As long as you have 2 points, you can make your line. And you'll see that the line was connected between here and here with an arrow going that way. Now part C says estimate the number of girls competing in 2017. Well, 2017 would be a total of 20 years since 1997. So we're going to plug in 20 right here for n. So the number of girls is going to equal 0.06 times 20 plus another 2.6 million. So 0.06 times 20, that's 1.2 plus 2.6. That's going to be the number of girls competing is going to be 3.8 million. Now you may want to pause the video and try this next example on your own. It says the Band Boosters are selling sandwiches for $5 each. They bought $1,160 in ingredients. Write an equation for the profit P made on N sandwiches. Well, the profit is going to equal $5 for each sandwich minus the expenses, which is $1,160 that they spent on ingredients. Because your profit is going to equal your income minus your expenses. So you're going to bring in $5 for each sandwich, and then you're going to subtract from that what you had to pay, which was $1,160. Now to graph that equation, we know the y-intercept is going to be at negative 1,160. So on my graph here, I chose to go up by $200 increments, and negative 1,160, it's going to be about there. It's going to be a little less than, or not quite, negative 1,200. Now the slope is 5, which means we're going to rise $5 for every sandwich. But since we're going by $200 increments, that's going to be kind of hard to find the next point on the graph. So I'm going to go ahead and just choose a number and plug it in. Like, let's go ahead and plug in 200 sandwiches. If I do that, it's going to be 5 times 200 sandwiches minus $1,160. So 5 times 200, that's going to be 1,000 minus 1,160. That's going to be a negative $160 profit. So if we sell 200 sandwiches, that's going to be right here at 200, it's going to be negative 160. So there's negative 100, there's negative 1 or negative 200. It's going to be somewhere around there. Let's go ahead and try another one as well. Let's do 400. If I plug in 400, the profit is going to equal 5 times 400 minus 1,160. 5 times 400 is going to equal 2,000. 2,000 minus $1,160 is going to be $840 profit. So for 400 sandwiches, it's going to be 840. So there's 800, there's 900. It's going to be about there. Now if we go and connect this with the line, it should go through those points. It's not going to be perfect because we're just estimating about where it would be. It's going to look something like that. Now part C says find the total profit if 1,400 sandwiches are sold. We can't really tell that from our graph because we'd have to go even further out here and it would be way off of our graph. So we're going to plug it into our equation. Profit is going to equal 5 times 1,400 sandwiches minus 1,160. 5 times 1,400 equals 7,000 minus 1,160. That means the profit is going to equal $5,000, $5,840.